Hi, this video is the first one in a series that are going to work through the solutions to the review questions to help you prepare for the midterm. So this video is going to cover questions 1 through 3. Okay, so we're given the scenario. Kevin has 20 friends. His mother told him that he can invite 13 friends to his birthday party. I want to know how many different groups of 13 friends could Kevin pick to invite to the party. Okay. So, for question 1, Kevin has 20 friends. He's going to be able to pick 7 of them to invite. Which 7 he invites doesn't matter which order he is inviting them in, because they're going to end up with the same group of people invited. So when I'm not concerned about order and I'm just thinking about how many different subsets of a particular size, that's when I use combinations. So I'm going to do 20, choose 13. I could write this also as 20, choose 13, like this. They're equivalent. And to find this, I can either, that would be 20 factorial divided by 13 factorial divided by 20 minus 13 factorial. Or if I'm working in a calculator that will do these combination calculations for me, I can go in and do that directly. So come in, I'm doing 20 in the TI. I choose the math button here, scroll over to the probability, scroll down to NCR, put in my 13, and press enter. And so there's my answer, 77,520. Okay. At the party, Kevin and his friends will be divided into 2 teams to play baseball. And we want to know how many ways the 14 can be divided into 2 teams. I'm thinking we're going to have equally sized teams, so teams of 7. So remember, we've got 14, and we're going to choose 2 teams. So we're going to choose 7 to be on the first team. But by default, the remaining 7 are going to be on the other team. And so if I just do 14, choose 7, I'm going to end up counting each formation of groups twice. And so I need to divide this by 2. So again, this would be 14 factorial over 7 factorial over 7 factorial, the whole thing divided by 2. And again, working in the TI calculator, that would be 14, math, scroll over, choose 7, and then I can divide that answer by 2. So 1,716 different ways that they could be formed into 2 teams of 7. And then the third question, this is the last one in the counting series. Once the 7 players on Kevin's team have been selected, how many different batting orders are possible? When I'm thinking about a batting order, now the order matters. I'm not just considering subsets. I have my subset, and I'm thinking about how many ways I can order it. So ordering is permutations. So I'm just permuting all 7 players. We could write this as 7 permute 7, but this is just equal to 7 factorial. So again, working here in the TI calculator, if I put in my 7 and then go to the math button, I can go down and do the factorial, and it gives me 5,040. All right, so that's the end of our first video.